Welcome back to the Village Clockmaker. I'm James. This is going to be a 3 or 4 parter, maybe even a little more, because we're going to make one of these. This is a fusee. This happens to be one I made 4 or 5 years ago in a that goes in a English skeleton clock, and it's fairly complicated. In order to cut this arc here, this is a true arc. It's not a yeah, it's a true arc. So in order to cut that, we need to make a tool to go in the lathe, and that's the first thing we'll do. And we're going to make, for stock, I've got this big piece of brass, which is big enough. It's got the right diameter and the right length. We'll have to cut it down a little bit. But let me go get the piece of steel we're going to use to make the tool, and we'll start with that. This is a piece of stainless, and I didn't particularly want to use that. I'm going to use 4140 or something like that, but this was what was available, and there's no reason it won't work. But what we're going to do with this, first we're going to cut a 1/2 inch slot across it, and this is the cutter. This is the cutter, and this will go down in that slot, and then there'll be 2 holes from the side, here and here, which will have set screws in it, which will hold this in the slot. There'll be 2 other holes here and here, which will hold it down to the cross slide. And this is not a ball turner. A ball turner, that's a lot of reflection. A ball turner is a lot more complicated, but all we have to do with this is cut one concave arc. So I don't have a ball turner, or I would do it with that, but the radius of the arc is 2 1/4, excuse me, 2 1/4, and I couldn't find a ball turner on MSC or any place that would cut an arc that big, so they're that long. So we're going to make this tool, and we're going to do it ourselves. So let's go over to the mill and set this up, and we'll cut this groove. Okay. I've already marked the center of this using the triangulation, but we'll double check it. Most guys I think would use a center finder with this, and if you want to be dead accurate, you need a center finder. But I use, for something like this, it isn't quite as critical. There, you can still see that. I use a laser, and I'm going to set this laser right dead center on my mark. And the tolerances on this are not, yeah, you can see this, you can see the center. The tolerances on this are not that critical. So we'll zero the X and Y. We'll go from this side. Let me adjust the camera just a little bit. I really like this laser. It's very, very close to being accurate. It's probably 4 or 5 thousandths off from being dead accurate. but the little laser point is 5/6 across, so you gotta now we'll go all the way to the other side. Right there. And we have 66 375 is 33.1875. So we'll go back to the beginning. Right there. And we'll go toward the center. 33187. There's 33185, and I would say we're dead on. We're right where we want to be. So that's a double check on the mark I made initially. So we'll just set this up and put a mill in, and we'll be ready to start cutting. In case you haven't seen one of these, this is the laser pointer. I don't know who it's made. Oh, here it is. SDA Manufacturing. I think they're 85 bucks, and you can turn it on and off right here. That little roller. Yeah. And they're very, very handy. I like them a lot. And they're a lot faster than a edge finder. Gotta get some Wonder Juice here. Only run in one direction so that I don't throw all the chips in the camera. So we've got taking about 15. try 20 this time. It's a little heavy, but there's 20. Okay, we'll rinse and repeat, and when we get down close to where we need to be, I'll bring her back. Okay, from the top of the cross slide to the top of the cutter is 0.922 if we want the cutter to be right dead on the center line of the lathe. So here we have, if we can get in there, camera makes everything a lot harder. There we have 0.931. So we want to take another 5 off. And we should be right on. .922, perfect. So we're going to come back, find the center this way, and at least start our holes there so we know where our 2 lateral holes are in the center. So we'll be right back. I had to change the camera around because naturally the Noga let go and dropped the camera right in all the shavings, so I had to clean that up. It's always something. Now we're going to go back 25 minus the other direction. I'm just marking these. We can drill them later, but I wanted to have them marked. There we go. Right there. Okay, we're ready to finish this tool up today, and I've marked the center cross line here so that we can go on both sides here and here at a given distance to put the bolts in that will hold the cutter. And I've measured this, the height of that we want to hit the center of the cutter here, and it's 1.64. So we'll mark that. There we go. Now we'll go back to the mill, and with a 2-flute cutter, I haven't measured the size yet, we'll go down into here on both sides. It's very hard to drill it, so we're going to mill with a 2-flute, which is the same as a drill. We'll drill down into there with enough to cover the heads of the cap screws, and then we'll drill the rest of the way through. Back in a minute. We're all set up in the mill, and I found the center point here with right here with the laser pointer, so we know. And then to make it level here, I put a parallel in here, set that down, clamped it so we know it's level. Okay. So now we're going to go. Well, we've zeroed the DRO, so we're going to go 15.0 right there. As I said, this is a 2-flute mill, which is the same as a drill, so that will drill down in there and give us a nice socket for the I have to do something about this whole setup because it's just not very good. Okay, ready. We're about 1100 RPM. And we did some liquid love here, just a minute. That bang you heard was me knocking my stool over. We're going to try some anchor lube here instead of the sulfate oil. It's not quite as messy, and works beautifully. want the bolt head sticking out a little bit. Set the stop on the quill. Now we're going to go plus 15 on this side. That's good. Vibrating because it's a 2-fluid mill, but I have to do that. If I had a 4-fluid, it wouldn't be doing that, but it also wouldn't be cutting down in. Unfortunately, this is not a Bridgeport. It's a middle-sized Rockwell, which is not quite as sturdy as a nice big Bridgeport. Okay. And it's very good. Now we'll take that out and put a drill in and go the rest of the way. We're set up. We're using 1024 cap screws, and this is a 25, number 25 drill, which is what we need for that, because that's going to be tapped, of course. So Okay. The other way. This anchor lube is very good. It does its job, and it doesn't make as big a mess. And it doesn't smoke. Looks good. As long as we're all set up, we might as well tap it. If I could keep my big hands out of the way there. And you can see how we're doing this. I'll finish tapping. I got all the dicam washed off, and here's our there you go. There's our clamping bolts. It's looking pretty good. The only thing left to do at this point is drill these holes, this one and this one. That will finish this part, and then we have to make some T-bolts to hold this down to the cross slide. So that'll do it for today. Thank you very much for watching, and I hope you enjoyed this. If you did, please subscribe and like and all that other good stuff that you can do. I wanted to show you anchor lube. This is anchor lube made by Anchor Chemical Company, Canterbury Road, Westlake, Ohio. And I think I got this from Tom Lipton. He had some and really liked it, so I bought a jar. It's real pasty, and it's, if you put it in a place, it stays there. It doesn't flow away like the oil does. So thanks for watching. I'll see you soon.